So now we're on graph linear functions, and that starts on page 262. And there's some really important things to understand here. Now normally when we see something like this, that means f times x. But this is a new way of referring to it, and that's called function notation. And what I mean by that is that basically, if you have something that says f of x, and the x is in parentheses like that, is equal to something like this equation right here, function notation, mx plus b. So it could be f of x is equal to 3x minus 2. And remember there, the slope is going to be 3. The y-intercept is going to be negative 2, because this here, in that case, is basically the y-coordinate. But again, it is not f times x, which is what I think a lot of people want to do. I'm just going to read this off to make sure it's very clear. It says here, the symbol of x of x, f of x, is another name for y, and is read as the value of f at x, or simply f of x. It does not mean f times x. You can use letters other than f, such as g or h, to name functions. So just be careful when you see the f of x symbol, which is this thing here. Be careful to know what it actually means. So here's an example. It says here, what is the value of the function f of x is equal to 3x minus 15 when x is equal to negative 3? Okay, so all we're going to do is we're just going to go ahead and, so I rewrote it out here. So in this case, the function f of x is equal to 3x minus 15. Now when the value of x is negative 3, then you're just going to put in negative 3 where the x is, and then just figure out what the actual value is of that side of the equation. So I solved it here again. For here, it's just we substitute in negative 3, so it's negative 3 times 3, so that's going to be negative 9. Negative 9 minus 15 is going to give us negative 24. And that's what the answer is here. So, for example, it says here, evaluate the function h of x is equal to negative 7x when x is equal to 7. And you can see what I did here is I wrote down h of x is equal to negative 7x, or negative 7 times x. And so h of 7, you just put in the value 7 there where the x is. So it's going to be negative 7 times 7, which is just going to give you the value of negative 49. So it's just a different way of noting it. Don't freak out about it. It's just, again, it's the equivalent of using y, but it's just slightly different, and it will be hopefully useful later. Now in this next problem, it says here, for the function f of x equals 2x minus 10, find the value of x so that f of x is equal to 6. So what we're going to do is this term right here, this one right here, is actually going to be equal to 6. And now we're just solving the equation here. So what we're going to do is we're going to add 10 to both sides. When we add 10 to both sides, we end up with 16 is equal to 2x. So x, so then we divide both sides by 2, and then we end up with x is going to be equal to 16. So the value of x when f of x is equal to 6, this value is going to be equal to 8, because it's actually 8 there, because it's divided both sides by 2. So hopefully that makes sense, and again, the whole idea is that you're, instead of solving the x side of the equation, you're solving the function side of the equation, the f of x side of the equation. So essentially you're kind of solving for the y part instead of the x part. So up here it talks about domain and range, and it's a similar sort of idea that the x is the is in this case going to be the values of possible values of x are going to be the domain, and then the values of f of x that correspond to the values of x are going to be the range. So very similar to the whole y and x thing in terms of what range are. So in this problem here it says the gray wolf population in central Idaho was monitored over several years for a project aimed at boosting the number of wolves. The number of wolves can be modeled by the function f of x is equal to 37x plus 7, where x is the number of years since 1995. Graph the function and identify its domain and range. So what they're doing here is basically, well, the function is going to start off with a range, or the domain, the first value is going to be 0, and then it's just going to keep going on, and then we're going to see what the range is. So the domain, it's listed right there, is x is greater than or equal to 0, because it's going to start off in 1995 and then go on from there. And we're going to see what the range is based on that. So let's try it out. So let's start off with 0, because that would be the first year in 1995. So then this value would be 37 times 0 plus 7. So that's just going to give us 7. So in the year 1995, that's 0 year. The value is going to be 7. So it's sort of like plotting points. This idea of doing it in a similar sort of way. So now if we were to do it the second year, it's the same function, so I'm just going to go ahead and erase that and rewrite it out a little bit. Here the function is going to be now the first year after that, so that's going to be 37 times 1 plus 7, so that's going to give us a total of 44. And then you can probably see the pattern here. The next year is going to be 37 more, so then that's going to give you 81. And so if we were going to go all the way up to now, if we wanted to, it would be 37 times 9 plus 7 would be the information about how many wolves you would expect to be there, because it's 9 years since 1995. And so if we were to do that, let's do the math. So if my calculations are correct, then you'd end up with a total of 340 wolves running around, which is quite a few wolves. But in terms of the actual domain, the domain is going to be this right here. It's going to be 0. X is going to be greater than or equal to 0. And the range is going to be f of x is going to be greater than or equal to 7. And that's what starts it. So now we're looking on this one here at a little bit different of a problem. Here we're solving for the function, when the function's value is equal to 155, that's equal to 37 plus x, as it says here, when the amount of, so basically here's what's happening. We're going to subtract 7 from both sides. You end up with 148 is equal to 37x. Then we divide both sides by 37. And I took a break to figure it out, and it's actually going to be equal to 4. So that's going to be the value of x when the function's value is 155. Again, very similar to what we've done before. So now we're looking at families of functions. Now, families of functions are ones that share characteristics, and the most famous one is going to be the one that we've been working with, plus b. Let's fix that a little bit here. So it's essentially saying anything that has this sort of format here is going to be what's called a linear function. That means it goes in a straight line. The most basic one is the one shown right here, which is just f of x is equal to x. And then if you notice, the slope is going to be 1, so it's 1 up, 1 over, 1 up, 1 over, 1 up, 1 over, and so on. But there's more complex ones, but each of them, in this case here, now we're on page 264, each of these are linear equations. In this case here, for the first one, g of x is equal to x plus 3. And if you're asked to compare that to f of x, is equal to x. That's what's being asked up here. So what's happening there is that plus 3 value, it has shifted the graph. The slope is still the same. Remember, the slope, even though it doesn't say it, the slope is 1 over 1, because the slope's value is just 1. So it's 1 up, 1 over for both of these. But it's shifted because of this part right here, this plus 3. So it's 3 higher up. That's why it's there instead of there. And now here's another one. It says here, so compare this one here. And again, the reason why it's using, in this case, h of x is equal to 2x. The reason why it's using h of x is because there's several different functions, and it's just a way of keeping track. You already have this function here and this function here, so now we're dealing with a different function instead of using y a bunch of times. I guess that's the main advantage for doing it this way. In this case here, oh guys, the slope is going to be 2. And yes, they have the same y-intercept, which is going to be 0, but the slope is 2, so that's how the graphs are similar. Same here, I'm not going to graph this, but it says here h of x is equal to negative 3x. And how does that compare to f of x is equal to x? Now you can probably guess, first of all, well, the slope, the y-intercept is going to be the same. It's going to be 0, 0 for both these. It crosses through 0, 0. But the slope, in this case here, we're going to be going down 3 every time we go over 1. Down 3 over 1, down 3 over 1. We're going downhill. And the opposite is true here. We're going uphill because it's 1 in front there if we had it the right way. So moving on here, what it gets at is this idea, and this we got into with the cockroach game. Here, the slopes are all the same. However, the y-intercept is different, and that's the reason why there's the shift. The lines are all parallel, but there's a shift that's different. Here, the slopes are changing, but the y-intercept is 0, 0, because there's no b on the y in the traditional. If we did the y equals mx plus b, in this case here, we're going to use the function notation though. Okay, so now. And this one here, the slope is negative, but they're still going through there because in these two here, the intercept value is 0. So therefore, that's why they're all going through that 0, 0 point. So it's sort of similar to what we were talking about with the previous lesson in terms of direct variation. So let's move on to the final page here. So we're now on page 265. So I'm going to read this problem off to you. It says here, a cable company charges new customers $40 for installation and $60 per month for its services. The cost to the customer is given by the function f of x is equal to 60x plus 40, where x is the number of months of service. To attract new customers, the cable company reduces the installation fee to $5. A function of the cost with the reduced installation fee is g of x is equal to 60x plus 5. Graph both functions. How is the graph of g related to the graph of f? Well, in this case here, well, look what's happening here. The function, the slope is the same because 60 is in front of the x. So they're never ever going to meet. But what would be their y-intercept is not the same. So they're actually shifted a value of 35. And so that's basically what we're getting at. And this is similar to that problem that I talked about, how I decided on which company to get my iPhone from in terms of Virgin Mobile versus Verizon, where the costs were different. In this case, it was a more complicated problem. But because the cost of the phone was different, and then also the cost of the actual plan was different. So I had to figure this out. And they would have crossed eventually, and eventually the Virgin Mobile company was actually going to be cheaper over time. And what it talks about is here, in example 5, suppose that the monthly fee is $70, so that the cost to the customer is given by h of x is equal to 70x plus 40. Graph f and h in the same coordinate plane. How is the graph of h related to the graph of f? Well, the idea being that, yes, they would start off at the same point because of that 40 value, because the 40 value would be this right here, is that part of it. But in terms of the slope, it would be a worse deal, because each time for h of x, for the second plan, you'd be spending $10 more. So first month you'd spend $10 more. The second month it would be $20 off. The third month it would be $30 off, and so on. And I'm not going to graph it, but I think you can probably visualize what I'm talking about.